Number systems, majorly we have 4 types, that is decimal, binary, octal, hexadecimal. So base value, okay, base for the decimal is 10, binary it is a 2, octal it is a 8, and hexadecimal it is a 16. Now why this is 10, 2, 8, 16 means when we see this value we will get the base values. Okay, so for the decimal it is a 10, right? 10 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9 it will contain 10 values, so that's why the decimal base value is 10. Okay, so in the binary systems, binary number system, the base value is 2 because it will contain only 2 numbers, either the 0 or 1. Okay, for the octal number system the base value is 10. It will have from 0 to 7, like 0, 1, 2, 3, 4, 5, 6, 7. So here there is a no 8 and 9. Now for the hexadecimal the base value is 16. Okay, so 16 means it will contain the decimal values. Okay, first decimal values 0 to 9. So 0 to 9 it covering 10 values. Now next after 9 we have 10, right? 10 is a 11, 12, 13, 14. So like this 10, 11, 12, 13, 14, 15 is represented as in English alphabet letters. Okay, A to F. So here 15 means obviously we will get 0 to 15, it is a 16 values. So that's why hexadecimal base value is 16. I hope you got the idea on the fundamental. Now let us directly move into the conversions, like one number system to another number system. There you will get the complete detailed idea on number systems. Okay, I won't want you to make the lag over this topic. So decimal to other number system. Okay, first when I write this like 152, it is a first case. Okay, first type from decimal to, let's take binary. Okay, base value 10 means it is a decimal, base value 2 means it is a binary. Decimal to binary we are converting. Okay, now let us take the example 152.25. so 1 we have, 5 we have, 2 we have, 2, 5 we have. This will comes under both decimal, octal as well as hexadecimal. So as of now we are considering it is a decimal. So we have 3 types, right? So to avoid confusion people will write base value as the suffix like this. Okay, to the binary we need to convert, so you need to mention the binary number, like binary base value as a suffix. Okay, I hope you got the idea how these things will work. Now here 2 means the final value should like something 0 ones, right? 0 ones, 0 ones, 0 ones, like this, right? So to this type we are going to convert. How we are going to convert means there is a method we need to use and we need to do conversion. Okay, now 152.25, right? So separate these two things, before decimal, after decimal. So okay, so we have point, right? Decimal point, before decimal point, after decimal point, the thing will be 152. Directly take as 152. Now do the LCM with 2 only 2, because here we have base value 2, right? So make a LCM with 2. So it is a 76, right? Again for the 76 it is a remainder 0. Again do LCM with 2, like 38. Okay, so now the remainder still it is a 0. Now when we do with 2, it is like 19. Again the remainder will 0. Again do with 2. It's like 2 9 ja, it is a 18, right? So now the remainder is 1. Write the 1 like this. Okay, I will show you. And 2 4 ja 8 and remainder will be the 1. Same way 2 2 ja 4, remainder is 0. 2 1 ja 2. Okay, remainder is 0. Now from here write like this. Okay, the flow is like this. It is like up to here we got conversion like 1 0 0. Okay, 1 0 0 double 1 triple 0 double 1 triple 0. Now again after point we need to do right like 0.25. So here we are divided, right? After point we need to multiply. So before point we need to divide, after point we need to multiply with 2, only 2. For the conversion is 2, right? So before point we need to divide, after point we need to multiply. Simple thing. Multiply with 2. Here we will get 0.50. Okay, this 0 right here. Same way how we written here. So after like before decimal point we have, right? So you need to take at a side and this thing right here like 0.50 into 2, we will get 1.00. So this thing right here. Now we have 00, right? 00 into 2 always will be 00. So means the multiplication got ended. So take these two values like 0 and 1 in this way. Okay, 0 and 1. This is how the conversion is. Okay, from decimal to binary. I hope you got the idea on this. Now let us do the same things for octal as well as hexadecimal. 8. Same way, divide it with 8 and multiply same thing with 8. Here we done with the 2, right, with the base value. Same way here we are going to do with 8 like 152, take a side like 8. So 19 ja 152, remainder is 0. Again 8 ja like 8 2 ja it is like 16 and remainder is 3, right? So write in the reverse order. We done with the before point. Okay, 2 3 0 point. Again we need to do with multiplication, right? 0.25 into 8, it is directly 2.00. After taking 0 there will be no effect. We need to take the 2. That's it for the like decimal to octal conversion. Next, so same thing, divide with 16, multiply with 16. Okay, 152 when divided with 16 it is like 9 and remainder is 8. Okay, so write in the reverse order like 98 point and 0.25 into 16, it is like something 4.00. Okay, write the 4 directly here because after multiplying 00 with 16 there will be no use, right? So this is how the conversion from decimal to other binaries, other number systems. Okay, in the number systems this is called as a least significant bit. Okay, least significant bit when compared to this like most significant bit. Okay, remember the terminology least significant bit, most significant bit, because in the further of these classes we are going to use this terminology. And the next conversion is binary to other number systems. Okay, binary to other number systems. Here write the things like this, like here you need to use positive powers, here you need to use negative powers. I will show you. 1 0 1 1 0 point 0 0 1, right? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So all you need to multiply like this and you need to sum. Okay, now same way here we need to use positive powers, I said, right? Here we need to use negative powers. After the decimal you need to use negative powers, like 2 power minus 1. Here already the 0 we got. Okay, so don't use 0, directly minus 1, minus 2, minus 3. So when you do this, here it is like 2 power 0 means it is like 1, it is like 2, and it is 4, it is 8, and it is 16. So 1 into 0, 0. Here directly keep the zeros, like 2, 4. Okay, and here it is like 16. Now 16 for 20, 22. So before decimal we got the answer 22 point. Now after decimal we need to find, right? So here it is like a 1 by 8. 1 by 8 is nothing but 125. Okay, so directly this will be cancelled out, right? 125. So like 22.125. Try to convert from binary to octal. Okay, so this is a binary number, we need to convert to octal, like base 8. So here it is a simple, you need to divide all these numbers into 3 parts, like 3, 3, 3 and 3. Same way after the decimal also, after the point 3, and here only 1, right? Okay, keep it as it is. Now you need to apply one rule, like 2 power 0, 2 power 1, 2 power 2. Okay, like this you need to apply for entire thing, 2 power 0, 2 power 1, 2 power 2. Also you need to apply same thing. Now here it is a 1, right? So you need to extend like this, like after the 1, if you kept zeros there will be no effect, right? Like after the point, whatever the numbers, when we attach with zeros there will be no effect. So here you can give 2 power 0, 2 power 1 and 2 power 2. Now do this, like you need to multiply like this and you need to sum. Okay, I will show first thing, like 2 power 0 it is a 1, 2 power 1 it is a 2. Okay, 2 power 2 it is a 4. Now 1 into 1, 1, 1 into 2 it is a 2, and 0 into 4 it is a 0. So in the combination now it is becoming 3. Okay, now let us keep the point, it is becoming 3. Now done with these things. Okay, same way ignore zeros directly, like 1 plus 4 it is like 5. Okay, otherwise I will show you, it is like a 1, 0, 1, 2, 4, right? Like 4 plus 1 it is a 5. Okay, now here like 2 plus 4 it is like 6. Okay, now here all presents means 1 plus 2, 3, 3 plus 4 which is like 7. Done. Same way do this, like here ignore zeros, we have only 1, right? Like 2 power 0 into 1 it is like a 1, and here ignore zeros, 2 power 2 means 4, 4 into 1 which is like 4. This is how the conversion will be. In binary to octal we have taken 3 sets, right? Here you need to take 4 sets, like 4, 4 and 4. Okay, ignore here, it is like a Gerazium. Okay, same way 4. Apply same thing, like 2 power 0, 2 power 1, 2 power 2, 2 power 3. Same way 2 power 0. Now here apply the same, 2 power 0, 2 power 1, 2 power 2, 2 power 3. Do same thing, like multiply and make a place. Okay, now to avoid confusion let us write 2 power 0, 2 power 1, 2 power 2, 2 power 3. Okay, 2 power 0 means it is like 1, 2, 2 power 2 means 4, 2 power 3 means 8. Okay, we have 1 0 1 1 means this 3. Okay, summation of these 3 will gives you like 8 plus 2 10, 10 plus 1 it is like 11. So 11 means directly you are not writing the 11. So in the hexadecimal format, like 0 to 9, 10, 11, 12, 13, 14, 15, right? So A, B, C, D, E, F. Okay, 11 means you won't write 11. You need to write B. Okay, so it is, we are going to convert into the hexadecimal, right? We have point also. So before the point, the first unit is B. Okay, I hope this thing is cleared. Okay, now let us move to the next set. 2 power 0. See here we have only two things like 8 and 2 power 1 means 8 plus 2 which is like 10. 10 means you need to write it as A. Now this thing is done. Same way 2 power 0 and 2 power 2 simply we have done right now, right? Like it is like 5. Now after the point, same thing, it is like 3, like 5AB 0.3 base 16 is our final answer. Now I hope you got the clear on these things. It will be a little bit confused. Try to watch once again, so definitely you will get the idea. Practice a lot. Okay, that's all for this video. Thank you for watching this.